Tēnā koutou katoa. No mai, harimai, ki te ao Mārama. Welcome, greetings. Thank you everyone for coming. We're really so excited to have you here. We've never put on anything like this with the background of the people who are here. I hope you take the time today at this event to learn about some of the people who've taken the time, who are interested enough to come along, because we've got people from all kinds of different backgrounds, all kinds of different interests that hopefully unite us together under this umbrella. And so welcome. We're excited that you can come and celebrate the opening, learn more about what Te Ao Mārama, the Center for Fundamental Inquiry, is about, what our vision is. But we're really here also to join in and ask for people from around the country to see if they'd like to get involved with us on, there's so many different levels, from our research to educational outreach. There's teachers here. There are people from all kinds of different institutions. And so hopefully today you'll have a chance to learn all about that. And what we're all about is cross-disciplinary research and outreach in the area of understanding the origin, studying the origin and evolution of the universe and its life. So that's what we're all about in a uniquely Aotearoa New Zealand perspective. So I will maybe just dim the light slightly now that we're all here. And we managed to fill the room, which is fantastic. So let me just sort out the lighting here. We'll just bring it a little bit down so we can see our beautiful images that we have for today. So I think you're aware of maybe the schedule for today because we've sent that to you. It's on the handouts. But just to go over it very briefly, we're not here to talk about details of our research today. This is a launch of this center. The schedule is that the executive group is here to gives you some introductory information about the center and about what has already been happening in this interdisciplinary space around our research and in our activities. So the executive group is going to give some talks. And firstly, I'm Campbell. I'm a professor in the School of Environment here at the University of Auckland. I'm an astrobiologist, among other things, and a geologist. And I wear several hats. And I'm the inaugural director of Te Ao Mārama. We also have here in the front row Emily Park, who's in philosophy, Richard Easter, physics, and Dan Hikuroa, Maori studies and earth systems processes. So we're here as representing a larger group, which I'll talk a little bit more about. And as you can see, then we'll have an acknowledgement of the center and an actual opening and kawanga ceremony about our official launch. And then in the afternoon, as you can see, because we've got these two aspects to our presentations, is that we want to have that open up after lunch. We'll be upstairs for networking and discussions. There's already a huge amount of that going on, which we're really pleased about, because there are so many places where we probably can look for commonality and places where we can work together on many different kinds of aspects of these big questions that we want to introduce you to and talk about. So we'd love to learn more also what attracted you to coming here and joining us today, because we would like to learn a lot more about you as well. So there'll be time for all of that this afternoon. But firstly, a little bit about us, your hosts today. We, the executive, represent a total of 14 founding members of this group. We've been working on this project for more than a year to bring it to fruition today. And as you can see, we actually span 8 disciplines and 4 faculties at this university. So science, arts, engineering, and business all are here in different capacities to joining as the founding members. We are supported through the Vice Chancellor's Strategic Development Fund until the end of next year, and it is the VCSDF that has allowed us to be able to bring you here today. So thank you very much for the funding and the support, and for you to come along and join us. Now, I want to give you a little bit of background about Te Ao Mārama before we launch into our individual talks, and we're going to spend about an hour doing this. So until about a couple of hundred years ago, most of you will be aware that science and philosophy, there were no divisions between science and philosophy. This was called the natural philosophy, and many natural scientists and philosophers, they came together to work on all kinds of problems in the natural world and to think about ways to think about the natural world. But we've got them now in separate disciplines, separate faculties, doing separate work, and some may come to think that, in fact, we can live with one without the other, that philosophers and scientists in particular don't have to actually talk to each other. And there certainly are many reasons why people specialize. We've got the Human Genome Project and many other kinds of questions that are answered because of detailed and deep specialization. But we're also here today to talk about the fact that other questions really lend themselves to bringing philosophy and science back together. For example, in my own area of studies of deep time, deep geological time, and also looking at the origin of life. These are questions that we all think about and that require us to come together and consider the implications and applications of this approach. Now, a little bit about our story, because many of you don't know how and why we got together here at the University of Auckland. So very briefly then, for many years, many of us kept crossing paths. We would be at usually educational outreach events because, how often would I go to a talk in physics? It wouldn't happen. We often were in our disciplinary silos. But we kept coming across each other in these outreach events. In this photo here, you'll see a couple of our members working on an outreach project down in Rotorua with a group with a Wananga program, Te Tomata Wananga, down in Rotorua. And we were there doing New Zealand and NASA Spaceward Bound last year with Māori youth. And it was in these kinds of interactions, and we began to realize we had quite a lot of research interests that overlapped, that we began to get excited about the possibility of working together and getting across the boundaries of our disciplines that always seem to come up and block our time and ability to work together. So this journey and sense of discovery was something that, well, we looked forward to whenever we would have our getting together and gatherings, particularly when we began to organize this event. And it's maybe similar, perhaps, to what the founding members of the Royal Society of London maybe thought about 350 years ago, which is outlined in Bill Bryson wrote a book, Seeking Further. And I was really inspired by that book because of this idea of the boundless curiosity that we kept coming up to every time we began to talk about these big questions. So we thought, well, why don't we give ourselves permission to create a space outside of traditional disciplines and give ourselves permission to ask these big questions. And so that's really, believe it or not, this style of engagement, we believe going beyond, seeking further, it opens up these new horizons and maybe allows us to ask questions about these big questions and work on them in new ways. And that's what got us going. That's what we decided to get together and try to put together something certainly new for us. So, some of you may have read our mission statement. There are many fundamental questions that people reason about. We are not the corner of the market on fundamental questions. But our focus is on fundamental questions about life and the universe. And these are grounded in the natural sciences. So we may be excited about life, the universe, and everything, but we do have these main areas that we've chosen to focus on. Okay? So foundational cosmology, examining the fundamental laws of the universe with a critical eye. Abiogenesis, fathoming the origin of life. Astrobiology, searching for further life in the universe beyond us. And some of these fundamental questions about life reach out and connect with fundamental questions about mind. And some of us work in that area of mind and cognition as well. And also, a number of the finally, and Dan will talk a bit more about this in his talk, part of our process is to also include Mātauranga Māori perspective in our reasoning about these questions and about life in the universe, to appreciate the ways that people think and know that are not just one way about our world, to stimulate new ideas and new thinking, and maybe even some of these are old ideas that some of us don't know about. So we want to learn about that. So that's what we're about. And we just thought we'd put up a few of these big questions just to let you know a few of the things that we think about, and they're pretty big. They're the sorts of questions that most of us will ponder about at some point in your life. They're pretty easy to think about and ask, but the deeper you go into them, the more you delve into them, the harder it is you find to answer them. So, for example, what are assumptions that we use in the search for Earth version 2.0? How do we reason about the existence of multiverses when we may never be able to touch them? Our life and mind, even the kinds of things that we can define. And Emily is going to say some more things about this, as well as Richard, in a few minutes. So here we are, launching today, and so far I've been talking about the idea that we could do some research around these questions, within the research space shown here, and bridging across these disciplines. But I also wanted to point out that we've got a big vision too, which we hope some of you, I know some of you are also working on, is that we can connect through education and community outreach across all of Aotearoa. and ask fundamental questions that really, for example, really excite children and adults, but we often forget when we grow up about them. So our starting point is here at the University of Auckland, but the point of today is not to say, hey, we're doing this at the University of Auckland. It's about a vision for Te Ao Mārama that reaches well beyond the University of Auckland. And that's why we've asked many of you to come today and join us, to build community across New Zealand within and outside these institutions. So embracing different points of view, cultivating dialogue with community, developing educational and other platforms around the deeper meaning of our place in the universe is very important to us. And it's notable, and I want to point this out, that this is current events, that there are places in this world, and they're not just corners of the world, but big places in this world, where topics like the origin of life and the meaning of geological time are not being taught in schools on purpose, deliberately. They're being left out of curricula. And that worries me and that concerns me. So through Te Ao Mārama, we're starting discussions with school teachers in New Zealand, some of whom are here today, to make sure that these crucial topics, we're still teaching about them in school, and that maybe we can participate in inquiry-based learning out in our communities. So that's a bigger picture of a vision that we've got, and I'm hoping that we can talk more about this in the brainstorming this afternoon. I hope we can do that. Now, this moment in time, why now? What about now? Here we are launching Rocket Lab, and a lot of things are going on. Why Te Ao Mārama now? We're not trying to just collect researchers under one umbrella and say we have common interests. We're hoping to genuinely explore fundamental questions together. We're wanting to do that. We're interested in doing that. And probably each of our founding members and many of you go out and excitedly research your topics. And so we can all make investigation of these questions. But we're hoping that coming together will make us bigger than the sum of our parts. So while we're driving this initiative out of our own interests and out of our own curiosity, it's also timely for New Zealand that Te Ao Mārama now exists. And despite our geographical isolation in the world, which we're all very well aware of, and it's getting smaller, by the way, every year, as we all know, the New Zealand science system is increasingly looking outwards and upwards. We're starting to really look in many, many places. And I know many of us, almost all of us, collaborate internationally. We understand that. But what we're hoping is that Te Ao Mārama will give us a platform to build connections in this interdisciplinary space across New Zealand and out to the world. So one example in my own space is that we'd like to build a formal relationship with NASA through the NASA Astrobiology Institute. And NASA has signaled through meetings that we've had with them that they don't want to just work with one institution. They don't want to just work with one kind of group of people, nerdy science researchers, nerdy philosophy researchers. Okay? They want to engage with larger groups of researchers and educators who have broad perspectives on fundamental questions across disciplines. So that's one of the many reasons to launch this center. So, and I did also want to point out there are other big questions institutes around the world. I'm not sure how many of you are aware of that. Some of us are very well aware of that. And we're very happy that they exist. In fact, we'll be establishing some MOUs with some of them. And they focus on life in the universe, but I think we have a uniquely New Zealand perspective to offer. There's nothing quite like this in New Zealand, and we've got some special things about New Zealand, two of which are our special geological context, which I could talk about all day long, but I promise I won't. Why is it so special to be here in New Zealand and not somewhere else? And also our perspective of Māori and Pacifica and other worldviews, I think, is clearly unique. So this is why here and why now. There are other opportunities as well for the researchers in the audience in particular, but we have also tapped into funding streams that aren't just about research, but about outreach through, for example, Unlocking Curious Minds. But I wanted to say that we can position ourselves to apply for research funding in spaces that would not be possible otherwise for individual researchers to do. So we've got opportunities, and I've got 3 listed here that are very exciting because both the Templeton Fund and the Foundational Questions Institute have much larger grant schemes that are about larger groups coming together to answer fundamental questions. And of course, the new Marsden Fund Council Awards we're very excited about because they specifically encourage creativity and innovation in these awards through greater connection between specialists across disciplines and within larger teams. So this is the kind of thing that people, not just us, but lots of people are thinking about. And so I hope we can have some productive discussions this afternoon around some of these topics, because this is quite a bit larger than just one or two of us saying we'd like to write a grant proposal next week. Okay. Now, I did want to say a few things about our values. There's sort of 3 core values that we stand for, and we want to kind of state them now in front of everyone and discuss them a little bit. And that is that certainly, first and foremost, our cross-disciplinary collaboration, we believe, as I said before, is more than the sum of its parts. So we are not just here to work on common points of interest, but what we're hoping is to genuinely learn from one another, and even potentially change the way we think because of the way and the people we're interacting with. And that has certainly infected all 4 of us at the executive and our larger group. We meet monthly in brown bags. My worldviews about the work I do have changed quite fundamentally. Secondly, we would like to have a lot of clarity around our communications about our ideas. And that's essential when you're working in an interdisciplinary space. Everybody's heard of jargon. And we're trying to minimize jargon, think beyond business as usual, and strive to communicate clearly, because that will help us not only understand our own work better and each other better, but then we can really reach out outside of our own disciplines to the larger community. So we think that's really essential. And then thirdly, respectful dialogue is crucial, because people see things from different points of views. Scientists, philosophers, the general public, senior academics versus students, Western and indigenous worldviews, and we want to strive for respectful, open, and inclusive dialogue here and across all the spaces that we work in. So we wanted to let you know that these are sort of some of our core values. And then finally, from this introductory point of view, we just have a list here that we put up of the actual core founding members of Te Ao Mārama, the 14 people who have initiated this research center at the university, and the specialty areas that contribute to some of the center activities. Now today we don't have time to go into detail about all these things. We are planning to run a research workshop in February that will get into more of this, and we'll say more about that this afternoon. But I just did want to point out that we work from meteorites to exoplanets. Okay, and though we could talk about life, the universe, and everything, but we do have our core questions and our core areas that we're interested in working in. So what we'd like to do is, if you see here, if you're interested in synthetic biology or other origin of genetic coding and a lot of other things, please feel free to introduce yourself. It doesn't matter if you're not from the university or you're not an academic. If you are going to join us after lunch, then please do introduce yourselves and talk to people about some of these things and what your interests are, why you're here, because we want to hear about that too. And in fact, we'll have introductions at the beginning of lunch, because it's a little hard to do that in here, but we will get to know, hopefully, you a little bit. So what we're going to have following then are just some examples from the 4 of us to talk a little bit about our areas and how working with Te Ao Mārama has affected us in good ways. So that's the plan, a recap of what we're doing. And I thought I'd just take a moment to just check in with you and see, are there any burning questions that anybody has about us at the moment? There'll be plenty of time to talk later. I see you're not shy out there in the foyer. We had already a lot going on. Francis Westall.
Sorry. Just a little comment. The term astrobiology actually defines the origin of the universe to us today and the future. So, I'm sorry, but I just saw it was a subset of all the other aspects.
We've got a cosmologist here, so remember, cosmology, it's got to have its own space. No, but we're... yeah.
I'm president of the European Astrobiology Network. I just wanted us to be all on the same page, because elsewhere in the world, astrobiology covers
everything.
Yeah.
Good one. Thank you, Francis. Francis is a That's fine. She's a distinguished visitor from France, from CNRS in France. She's with us for the next 2 months. All right, well, there'll be more questions, I'm sure. I get to be the one who starts the list of 4, so I'll just stay up here for a few minutes, and you've already heard a little bit about me. And as Francis rightly pointed out, astrobiology by nature, by its very right to being, is extremely cross-disciplinary. And some of the key topic areas that are covered by astrobiology are shown here. And astrobiology also uses the tools of many sciences. And what I was astounded by at the recent astrobiology conference in the US in April was that they had a session for students beforehand where they had experts from all the different disciplines giving tutorials on their topic areas so that you could go to more talks and understand more things. And I was very impressed. In fact, the students who go to these meetings know a lot more about a lot of different sciences than I will ever know. So that was quite impressive. But not only is science part of astrobiology, but it also deals with ethical and philosophical issues as well. For example, planetary protection, or how should we approach extraterrestrial life if we were to ever encounter it, be it intelligent or otherwise. So it covers a broad brief, as Francis pointed out. Now, astrobiology in New Zealand, in Aotearoa, one distinctive area of astrobiological research underway here is using extreme environment analogs to help us pinpoint where earliest life on Earth might be and focus our search for possible life elsewhere in the solar system and beyond. So we're replete with modern and fossil extreme environments, and particularly hot springs, which are shown on land and in the sea, which are shown in red, and also offshore up in the Kermadex and the hydrothermal vents. And we also have all these marine cold springs bearing hydrocarbons, which are shown by all the other colored dots. So it's been a fantastic playland or wonderland for me the last 20 years that I've been here. The point being that we are surrounded by world-class natural laboratory. New Zealand is famous for that. Not that many people manage to get over here, but we're trying to change that with some of the meetings we're planning. But we've got unique features that help us contribute to this massive global effort going on to search for life somewhere else. And so I can't really overstate that enough. I know it's my area, but now my group for the last 2 decades has been developing these high-resolution environmental models for looking at hot springs, modern ones and fossil ones. These are gorgeous hot springs microbes. They still have their color. They're fossilized. They're from Tokanu. So we apply the knowledge gained from, without going into the details, I'd love to tell you about it, but I know I can't. But we've actually been able to use these models to obtain a much deeper understanding of the context of early life in places on Earth where these very old rocks exist, which is not here in New Zealand. Our oldest rocks only are 500 million years old. So we go to places like South Africa, where Frances works, and she invited me to work there with her, and also Western Australia, where we've got rocks that push over 3 billion years old. And here, just an example, you can see that rocks are beautiful. I know I'm biased. They have very distinctive textures to them that even you can see, even if you're not a rock person. And those are very, very informative when they're placed in the context of these models, these refined environmental models. So the very old rocks in Western Australia are the 2 upper ones, and they compare very favorably to young New Zealand deposits down in the lower ones. And this so much so, on the right are where the hot springs geyser out, and on the left are fossil microbes that are 3.5 billion years old. And we were able to, without going into detail, determine that the earliest life on land, at least so far, seems to be in Western Australia because of our input. And that just brings us to a much, paving the way for discovery of where early life took hold on Earth, and brings it way back to the time of when life was really starting to diversify. In fact, life had to have originated even before this because it was so diverse even where we were working. Now, one of the things I have learned in coming back around to NASA, I had a postdoc there many years ago, and what I've learned in interacting with people there and learning from Francis about the European Space Agency is that it's always very important to examine your assumptions about anything, including the models that we develop over 20 years. You've got to always be examining your assumptions if you want to narrow the search for life somewhere else. And that's because in current and the near future missions, rover missions to Mars, which are all coming up and some are ongoing now, they rely on these Earth analog models They rely on them to help them figure out where to search, what to know, what to expect in surface conditions, and what would be the state of the organic matter that might be present on Mars, on the red planet. And what I've seen is that people often carry hidden or very obvious biases in their views about their favorite sites or their favorite instruments, and sometimes potentially hampering creative or logical thinking. I mean, we all have our favorite pet projects, right? So I think we need to continually evaluate our assumptions about where to search and what might constitute life once we get there. And I've really learned a lot from that. So here, closer to home, if you keep a broad perspective and examine some things in detail, like these minerals and microbes shown here on the left, you might be able to compare your findings then with what the rovers are finding on Mars, which is shown on the right there. That rock hammer has been added on. That's fake. Fake science right there. Asking the question, can we locate Earth version 2.0? And we are talking about microbial life here, not the aliens that are on Star Trek. But we really need to test what we know in a very robust manner. And these unusual deposits clearly are made by microbes that have silica growing on them from the discharge in the hot spring. So is that the correct model for what we might be seeing on Mars, what one of the rovers has already located on Mars? Or is this just windblown erosion on the surface today? What is that, those little finger-like things that are 3 billion years old? 2.4 billion US dollars are at stake. So we really better be thinking about what our models are and how we are grounded. And our hopes and dreams of exploring Mars for life hang on these kinds of ideas. And beyond Mars, new targets in search for life have come up in just recent years, have been discovered in recent years, like plumes of water ice and silica shooting out of the southern pole of Enceladus, a moon of Saturn, which has an ocean underneath that ice. And so the mechanism suggested here is that maybe there are vents, hydrothermal vents, or jet-like stuff coming out of the bottom of on the rocky part of the planet, and maybe like methane flares or natural gas flares that are shooting out that we've got just offshore of New Zealand. We actually have flares that are similar. And so a NIWA study is just getting underway with us and others, trying to understand how these flares might form here in our sea, and whether they might be delivering nutrients to extreme life offshore or on another planet. And Nick Rattenbury, those of you who don't know him, please say hello to him today. He's looking at exoplanets with gravitational microlensing, trying to find more Earth-like planets outside our own solar system. So there's plenty going on around here. And my last slide is just a tipping to the Earth and space science education curriculum in New Zealand, some of which is quite new to the high schools. There are teachers here today. We are already working with local middle schools, trying to set up inquiry-based learning models in the nature of science strand. And we hope to extend these partnerships to some of the high school teachers locally who are here in the Planet Earth and Beyond strand to create dynamic learning opportunities. So I hope we can have some discussions later today about this as well. So I will wrap up my bit now and ask Richard to come up and talk about cosmology, please. Thank you.